老师想问下，
先等3分钟，看下指引他们来接回来。 Okay, let's start. Right, so similar to the integration in a rectangular coordinate，哎，你们看的时候会懵吗？其实我要 try 一下跟老师讲的一个 trick。Okay, it works off on off. The lecturer said just now. So let's continue. So, similar to integration in regular coordinates, we also can do polar coordinates over general region here. So meaning it is not a proper polar rectangular, but some side. So in this case here, you can see that the two sides of the polar rectangular is depending on theta. Is depending on theta. Or you could imagine that you have can I have radius? Yeah, you could have radius controlled by angle also. So you can solve the relationship. Okay. So let's say there are two side radius here is controlled by theta. So what can you do? You can integrate over r first. so that you place everything in terms of theta and then you integrate over theta. Okay, does it make sense? Does it make sense? Question? Okay, so let's try another example here. So let's use a double integral to find the area enclosed by a loop, okay, of one of the four leaf rows. Right, so but in principle, double integral is computing a volume, but here they ask you to compute an area. So what should you do? What's the function you should integrate over? What's the function you should integrate over? What's the function you need to integrate over to find an area? Okay, we just discussed this in the morning, right? 1, good, very good. So 1, okay, 1 over this area that you want to find, this area of this domain here. All right, yeah, so how should you describe this D? Can we use polar coordinate to describe it? So meaning, can you write D as R theta? Okay, so what's your R, what's your theta? Any idea? What's the angle, what's the radius you need to use? Which one is easier to see? Angle or radius? Angle, right? Okay, angle from what? From where to where? Huh? Minus half over 4 to half over 4. But how do you describe this kind of leaf? How do you describe it? How do you describe this leaf? This is exactly the polar graph. Exactly the polar graph, right? Okay, so you take everything from radius 0 and then following the polar graph here. Okay, so you get everything from 0 up to the, what's your polar graph in this case? Cos 2 theta. Okay, so this is given here. Okay. So if you want more leaf, what do? You increase your angle. Okay, increase your angle. But radius is fixed. All right, so this is your domain. So you write your dA in terms of dr d theta here. But in this case, you need to have an extra factor of r. Okay, when you change to polar coordinate. And which one should do first? So since our radius is depending on theta, we should integrate it first. And then integrate over theta. Can you quickly compute what is this? This is a simple exercise first. Okay, try and compare and then we compare answer. What's the final answer again? 1/2罢了，1/2啊，这样子。Things should have pi 耶，算到什么？算到什么来着？啊？你怎么知道你算错呢？我都写一个 R。哦，你都写一个 R，OK OK OK。还有嘞，还有什么答案？讲不用紧。Yeah, pi over bar I think is correct. Pi over bar. Try check. Do you get pi over 8? You forgot that R or not? Am I any problem calculating the integral? Am I 有没有哪一步你要看一下是怎么样的？The other one you should get 1/4 of theta. So let's write another intermediate step. So it's 1/4 times theta plus sine 4 theta over 4. You should get this. Okay, in another intermediate step. You should get this one. Okay, 有吗？有算到吗？ So basically, you should be checking these two intermediate steps here. Okay. Yeah. Okay. And let's continue. Okay, how about this? Volume of the solid under this surface here. Z equals to x squared plus y squared. And then above xy plane inside the cylinder. So basically, you are finding the volume under this, what do you call this? Under the cone, but inside the cylinder. So cylinder here bound a circle. Okay, bound a circle here. So your domain is a disk. Okay, it's a disk. Close disk. Improve. So if this is a circle, can you quickly give what is your D? How do you bound your R and theta here? Since it is a circle, right, maybe it's easier to use polar. But be aware, maybe the question is easier to integrate in XY. So you need to be prepared, okay, that you can write this domain in both way. Okay, in both way, you need to prepare. So let's say if we want to write in, okay, so let's write in XY first. So if you're gonna write in XY, what do you need to write here? So it's all the XY in R2 such that XY will satisfy the circle equation, but you take everything inside. But the other way to write this in a polar variable is what? How do you take r theta? Which one is easier to determine first? Hey, this one a bit tricky. This is the first polar graph we draw last time. Not sure you remember. We draw it plotting point by point, angle by angle. What's the whole period of this circle? Do you still remember? 0 to 2 pi or 0 to pi? Actually, only 0 to pi. This is the very first polar graph we plotted out last time. Okay, so actually you just go from 0 to pi, you can plot everything already. Okay. How about the radius? Radius going from where to where? 0 to what? Radius. What's this outer circle here? Who control this circle? Who control this circle? So, one 的图案是长这样的，1的图案是长这样吧，对吗？0到1，然后0 to 2，but not quite right. We want this circle. This special circle, who can plot this special circle? What's the polar equation that plot this circle? Cos theta. Okay, so this outer circle here is plotted by 2 cos theta. Okay or not? Yeah. Okay. If you are not sure why this one is 0 to pi, you can plot it in here. Okay, so if you plot theta equals 0, what do you get? Radius is 2. And then if you plot theta equals to pi, what is 2 cos pi? Minus 2. Correct? Minus 2. So minus 2 angle pi means what? You need to turn it back. Okay. Correct or not? Okay, so let me ask you a question. So what is minus 2 pi? Where is this point positioned at? This is equals to what? This is equals to the point 2, 0. Why? Why? Still remember? What's the relation between r and minus r? You reflect on the line that join to the origin. Okay, so we reflect it back. So actually, this point is minus 2 pi and 2, 0. Okay, so we reflect. So what am I reflecting? I'm reflecting the point 2 pi here. Okay, so if it's a negative radius, you need to take it back. Okay, on the line that join 0 to itself. Does it make sense? Okay 吗？还记得吗？还记得吗？ Yeah, 忘记不用紧 but please recall. Okay. Yeah, so let's see. Is it easier now? So what should we do now? So what's the function of two variables that we want to integrate over? What's the fxy here? What's the surface we're interested in here? X squared plus y squared. Okay, so we want to integrate over x squared plus y squared here. And do you want to use dx dr or dr d theta? Up to you actually. Okay, but in this case, since our domains looks like a polar rectangle, we just use dr d theta. But make sure that you have an extra factor r. Okay, so integrate over r first because our r is dependent on theta. Okay, so notice that I haven't replaced my x and y. Okay, so what should I do? X squared plus y squared is what? It's just r squared. Okay, using x equals to r sine theta, y equals to r cos theta. Okay, so you should compute this. Okay, I think the answer is just 3 power 2. I think we won't go through the calculation, but do you know how to build this integral? Given this question, do you know how to build it? Any question? So the main point is to build this iterated integral. Okay, how to see from your domain. I think the technical point is here, how to write down this D. Okay, it's really important. You see, we are using what we have learned before, using the drawing the polar graph, right? How to draw up this polar graph here. Okay, and now we are integrating over everything inside this polar. Any question so far? No question or no? Is it clear? Yeah, you can try and do the dy dx square also can. Okay, any question before we go to triple integral? Okay. So next, we'll go to triple integral here. So we also define triple integral using rectangular coordinate first. So meaning the now is a bit different. Now our domain become cuboid. Okay, become cuboid. So imagine calculus of one variable, your domain is a line. interval. But function of two variables, the domain is what? Maybe a circle, a rectangle, I don't know. But now the domain is cuboid itself. There's a cuboid itself. Okay. So imagine what's the volume under the cuboid or 3D shape. What is that? Okay, in the textbook, they will call it a hypervolume. Okay, but not sure how to draw it. Hypervolume because it's something in our book. Okay. So if you want to look at a cuboid domain here, obviously you have x, y, z. So there are three ways to cut down your cuboid. Remember, in calculus of one variable, there's only cutting in x direction, right? And then in two variable, you cut the square in two direction. You can cut in x, cut in y. But now you cut in z also. Okay. So in this case here, the triple integral become triply limit of triply sum. Okay, triply limit of triply sum. So this picture here is not hypervolume yet. This picture is just a domain picture only. You are just cutting the cube. Okay, we cannot draw R4, so we cannot draw you the hypervolume. Okay, so this picture is equivalent to cutting the square inside function of two variable here. Okay, and then one variable, you are doing the Riemann something, put a lot of subpartition like that. Okay, but yeah. So similarly, we have Fubini's. Okay, we also have Fubini's. If a function is continuous on the cuboid, or they call it box sometimes, then you also can change your order. How many order you can change in this case? There are three variables. 6. Right, 6. There are 6 order you can do. Just now, like, 2 variable, you only can do 2. So here you got 6 order that you can compute to the same thing. Right. Okay, let's see this. Okay, so first example, obviously is easy. I just give you a box. Okay, I give you a box and then ask you to use Fubini's because your function is continuous on the box. Okay, so if f continuous on the box B, then you can use the 3 variable Fubini. So you can imagine you can extend this Fubini to different n, okay, higher dimension n. So what's this box? In the x direction, is going from 0 to 1. In y direction, it's going from -1 to 2. Okay, in the z direction, it's going from 0 to 3, like this. Okay. So if you're gonna evaluate this, pick any one of your choice. Pick any one. Okay, you want to do dx, dy, dz, dy, dz, dy, dz, dx, dy. Do it. Okay, let's see if we get the same answer now. Pick anyone. Anyone that you like. Okay, after 2 minutes, we try and compare solution. Okay. Anyone try dx, dy, dz? Who try dx, dy, dz? You try, what do you get? 2714. Anyone try others? dx, dz, dy? 亲生 try 冇？什么叫拆开来啊？哦，你拆到完了。 哇，还没有教那个诶，那也不会动到，但是是可以猜吧？应该是可以，应该那个 theorem 是可以 generalize 的呀，那个 theorem 应该是可以 generalize constant 的。应该不是这个原因啊。对对对对对，但是那个 constant 只是让你记住啊，就是它 act 来的 constant，但是它原因应该不是那个，你要用那个 triply limit triply sum 去算。Yeah. Yeah, this theorem, whenever I speak to you or ask you to remember, it's just a mnemonic way to remember how to use it. But the actual reason is you need to use the triply limit, triply sum to compute it, to verify it. Okay. But the result is keeping one constant. Okay. So be careful, because when you go to higher max, then it's a different reason. Okay. Anyone compute the others? 第三你算哪一个？一样啊？怎么你们全部这样合群呢？子莹呢？dz dy dx，OK，算什么答案？Good，21.4。还有吗？还有其他人吗？算不一样的。会写。第一个，OK，check you 也是第一个，OK。这样你们是真的很单纯诶，你们班全部都是 dx dy dz，可以试试不同的东西，其实回家 try 一下回家 try 一下。因为我们学术界是这样，我们应该要百花齐放。如果只开大红花的话，就很丑。对啊，我们要百花齐放。OK，自己要有自己的 idea，然后 try 一下。OK，next，similarly, we'll do it for general region. So what kind of general region you can get here? So for example, you can have a D, and then let's see. So what's this region here? Let's look at what's E. E is X, Y, Z, such that X, Y is in D, and then that is controlled by two functions depend on X, Y. Okay, so can you see that this D and E looks a bit different? Look a bit different. 有看到它的 shape 有点不一样啊。Okay, so meaning what? Meaning that if you look at a fixed Z, okay, you have a different area. Okay, you have a different area controlled by U1 and U2 here. Make sense 吗？想一想 make sense 吗？ What is D here? So we should fix D first. Okay, so let me see. This. After we fix a D, and then this Z, I mean, let's see. Okay. Oh, I guess. Okay, Okay. So how should we read these? If you look at this equation here, how do you read this? Which one is fixed first? Okay. X by fixing xy means what? You need to pick your D first. Okay, so you are considering only points in D. Okay, only points in D. But this is a triple integral, right? Your domain not just it's not just this D. You need the height also. Okay, you need the height because your box has height. So what's the height here? It is bounded below by a function in xy, bounded above by a function in xy also. Okay, bounded above and below. And then you can see that in this case, I think there's some bug here because the shape should be the same. Okay, the shape should be the same. But why it draw like this? I think it just trying to tells you that the height here maybe is a bit higher than the rest. Can you get what I mean? Can you get what I say? So okay, so let me throw you a simple case. Let's say you want xy equals to 1, U1, U2, X2 equals to 2. What's this shape here? Let's say this D is let's say 0, 1 time 0, 1, 0, 1 also. So what's this shape here? Okay, so let's take this. D equals to 0, 1 squared, and then U1 xy equals to 1, U2 xy equals to 2. So how do you draw this? So let's start from xy plane. So xy plane like this. Okay, so where's my D? 0 to 1 cross 0 to 1. So it's this place here. Okay, but what's the height? It's a constant function 1. Okay, constant function 1 means what? You lift the plane up by 1. Okay, so here is a constant function 1. And then constant function 2, again, you lift the plane higher 1 unit. Okay? So everything in between. In this case, what do you get? What do you think? You get a box. Okay, you get a box. Okay, of height 1 and then length 1 also, width 1 also. Okay, does it make sense? So well, I mean, you could replace the 2, right? Can you replace with something interesting? Interesting function. Can we do something interesting here? Well, we do 2 minus x squared minus y squared. You know what happened if I change this to use 2 to this? 2 minus x squared plus y squared. Does it work? Or should I lift it up more? I think. So I'm trying to build a partial dome here. 哎，知道我在讲什么？全部人掉线了。So I mean, okay, wait. Let me see how to put this. So okay, so how to describe this sphere? So this sphere is z equals to so should I use z? Yeah, use z. Z equals to square root. Square root of what? Sorry?
The constant.
Okay, radius square, yeah. So let's fix this radius. Radius 1. Should I get 1 here? Radius 1, and then okay, let's try something tutorial. Let's try to draw something special here. Okay, so let's call this r. Okay, let's do it r in general. So you will get r squared minus x squared minus y squared, right? Okay, so this is the upper half, upper hemisphere. Okay, so the lower hemisphere will be minus. Okay, let's say okay, I want to attach this part to my box. Can you imagine or not? Okay, I want to attach this part to my box. So how do I make my sphere sitting on this box here? How to sit on the box? So well, I mean, I need to cover at least up to this diagonal, right? So this diagonal become my radius. So what's the radius in this case? 1, 1, so square root 2. Okay, so the radius should be square root 2 here. I think I'm enough, right? I'm enough. So from this hemisphere, so square root 2 is 2. 2, and then take the square root. But there's a problem here. What's the problem here? This hemisphere centered at origin. But this, I mean, can I do this? Is this enough? So where should I put my center? Lift it up. Here's your 2, huh? Okay, so 0, 0, 2. So how to change my U2 here? 0, 0, 2. So y minus 2. So I shift my hemisphere up. Then I can attach this dome on the top of my box. Okay, does it work? Oh, Z minus 2. So we need to minus and outside. We shift the plus 2 plus 2, right? I shift the sphere up. Okay, yeah. Can you imagine or not? Okay, so let me move this one. Actually, I have a sphere like this, right? But I want to put this sphere on top of this box. So I need to shift my origin up to this place here. Okay, come on. Can run see? Can see? Okay. So this XY will kind of like restrict what kind of height I can place on here. Okay, so XY already did the job. So I'm fine. Because my XY already fixed around this box here. Okay, so only this dome will get attached. Okay. 有问题吗？没有。Okay, 明白。Yeah. All right. How about the other one? Okay, so this is type 1. Type 1 solid region. Second type. Okay, what happened to this second type here? So this second type here, we start with X. We just fix X. Okay. X is fixing from A and B. So where's X? So we only know about our X live in A and B. So for a fixed X, okay, so for a fixed X, the Y is controlled in terms of X. Okay, so you give me one X, I know what is the Y interval I'm gonna get. So let me draw this. So if you fix an X, I know the Y interval. So make it big here. Okay, so the Y is controlled by two functions in X, and then you will do what we did just now. These points in D is controlled by U1 and U2 in the Z direction. Okay. Okay. So I mean, again, check whether this multiple integral makes sense or not. Does it make sense? So you integrate over Z, but Z is dependent on XY. So meaning what? You replace all the Z with function in XY. So your function only left with XY variable. And then you integrate over Y. But Y variable depends on what? Depend on X. So again, you replace all the Y in terms of X. So in the end, you are left with all the X's. So you integrate over X. Okay, yeah. So whenever you try these, check that your integral makes sense. Okay, makes sense. So they will compute a number. So you can do variation. Okay, all those are variation. Yeah. So let's try. Yeah, let's try this example. So let's try this example. Okay, so what's this example here? So evaluate the triple integral, okay, of Z dV, where E is a solid tetrahedron, okay, bounded by this three plane here. So one plane is x plus y plus z equals 1, and then x equals 0. X equals 0 is what plane? ZY plane, good. Oh, this one is ZY plane. Y equals 0, x, Z plane. Z equals to 0 is what? XY. Okay, so you can see that is the tetrahedron. But in this case, be aware, we are computing hypervolume or not volume. Okay, so this E is just domain. Okay, it's not the volume that we do for double integral. Okay, so you need to imagine this tetrahedron like repeat a few times tetrahedron. Okay, so this depends on Z. Right. So, well, is Z continuous on this box or not? Z is a polynomial function, right? So it should be continuous. So, which order you want to do in this case? So you can pick any order. How many order you can pick? There are 6 of them. Okay. So which order you want to pick? You want to fix one? Which order? Huh? Z? And then XY? Can, sure. Okay. So the order that we fix this integration domain is kind of opposite, right? We should start with Y, X, and Z. Yeah, because in principle, Z will depend on X, Y, and then X will depend on Y. Because in the end, we want to compute a useful number out. Okay, so the last thing we integrate should be number. Okay, integrate over. So where's Y going from where to where? What do you think? Looking at this picture here. What's the lowest point? What's the highest point for Y? 0 to 1. Good. Okay, so if you look at 0 to 1, how do you cut your X off? Very interesting question here. How do you cut your X? So here is a 3D shape. So this is kind of a case that you want to be aware of or be careful. How do you slice your X if you fix a Y? 啊，跟 X 平行是什么意思？So well, I mean, you fix your X, right? Okay, you fix your X. Sorry, you fix your Y first. Okay, and then you see how your X's change. Okay, so can you notice that when the Z get higher, this interval also changes. Did you see? Did you see? Okay. So, so how should we do it? Let's think about it. Huh? Let's say again, which point? 0, 0, 0. Yeah, think slowly.
Y 等于那条线到那个100的点，到010的点。
010, this one? 010, sorry. Oh, you mean the okay? You mean the this triangle here? Okay. How about this? How about this line? X 等于减. So why are you trying to describe here? What about this triangle here? Yeah, correct. Yeah, sure. Oh, you mean you mean okay? So you mean the intersection of x plus y plus z equals to 1 and z equals 0, correct or not? Okay, so we're actually integrating from x equals 0 to what line is this? Oh, sorry. Yeah, this line is what? How to get this line here? You know how to get this line? How to get z equals to 0. Okay, so what do you get? Y equals to 1 minus x. 对吗? Oh, sorry. We should use y, right? 1 minus y. Is it? 对吗? 1 minus y. Okay, so this line here is 1 minus, so x equals to. 问题吗? Okay. 问题吗? Okay. Hey, which one? Okay. How about that? 0 to 1 minus x minus y. Why? 为什么呢？为什么 How to see this? This is a very important point now. How to see this? So if you want to fix z, right? Okay, z is depend on x, y. So meaning what? If I pick any x, y here, you need to tell me the height. Okay, so who decide the height? So in this case here, who decide the height? Exactly the surface. Decide for you what's the height. How far you can go? You cannot go beyond the slanted plane. Okay, that's the most you can go. But what's the minimum you can go? It is bounded below by z equals to 0. Okay. Okay. Does it make sense? Maybe if you're not sure, right, we can try a few more. We can try a few more. Let's do another direction. Let's do the other direction. Calculation you can do yourself, but let's do different direction. 来，这个叫什么？ Before 来选一个方向，然后你自己来做，选一个方向。来，还有 S 跟 Z 吧？随便。哈？啊，你讲一个。X. Okay, good. So let's do this. Y, Z, X. So we fix Y, fix Z, and then fix Y. Okay, so X should go from where to where? What is the lowest X? What is the largest X? 0 to 1. Okay, so if I fix X, I want to see what's my Z. Okay, Z controlled by what in this case here? So you see, when X equals to 1, Z is just 1 point. Okay, but when X equals to 0, Z is from 0 to 1. So controlled by what? Huh? Z bounded below by what? Bounded below by 0, obviously. Okay, but how to get the upper bound here? Where's the upper bound? For the upper bound, how to get it? Should be this line here. Correct or not? Is it this line? Okay, so how do you get this line? How to obtain this line? So you sub y equals 0 into your plane. Why? Because it is the intersection between zx plane and your plane. Okay, so y equals 0, what do you get? Plus z equals to 1. So you get 1 minus x. Okay, good. All right. So now you need to determine what's your y now. So y here will depend on x and z. So where is s and z? Is this plane here. So give you one sz point here. You need to tell me what's the interval for y. Okay. Who control this? Again, still controlled by plane equation. Okay. So it will be going from 0 to, what's the plane equation here? 1 minus z minus x. Okay. Yeah. So a very good exercise. How many ways? 4 more ways. Write them up. Okay. I will provide in my lecture notes. Okay, I will provide in my lecture notes here. Okay, so let me show you the picture. Let me show you a picture. So in principle, how do you start the game? So how do you start the game? So let's say we want to do dy, dx, dy, dz. Okay, so meaning you need to fix your z, y, and x first. So if you look at your tetrahedron, your z is going from 0 to 1. So really, you just start with a line. Okay, 0 to 1. But how to get y? Okay, how to get y is you need to look at the slice of x equal to 0 because you look at the zy plane. Okay, so it's x equal to 0. So how to build your slices of x equal to 0? So in this case here, like what we do just now, we look at the intersection. Okay, you look at the intersection. And then you can see that the intersection of zy plane and your plane, cylinder plane, is setting x equals to 0. And then you get the 1 minus y there, the triangle. Okay. And then how to build the whole tetrahedron? Okay, to build the whole tetrahedron, what do you see? What do you see? You see the slices from the other way. Okay, let me see. How should I see what I draw? Where I'm starting? Let me think. So, well, I don't show you these. I show you mine. Show you mine. Let's show. Let me point to. So we start with z in this case here. So where is z now? Z should be on this side, right? Okay. And then we draw the x equals to 0 slice. This is the zy plane. So zy plane is here. So okay, so to be sure, so here is x, here is y, here is z. Okay. So we start with z line. Okay, because we only talk about zy, so we will look at the zy plane. So it is this one. Okay, you build this triangle. But how to build the rest? So you should imagine that the rest you should put a bunch of triangle together. Imagine 了，好像翻书这样，对吧？像翻书这样，就有很多页这样被打开。懂没是吧？有没有一本书啊？借我看。有没有书？现在人还有带书来上课吗？啊，有吗？可以，没问题。OK， 哇、wow. Principle routine 呢？这个精华的 routine。OK， so you see you start from one planar plane. Okay, how to open up to tetrahedron? Okay. But in this case, it's triangle, not this one is square, but we want triangle only. Okay, so we 打开一下，一页这样，对吧？因为它很密集，所以我们说这个。现在有一点难做给你看，对吧？懂什么意思吗 ？Okay. So how to form that? You will use the plane equation then. I use the plane equation. 看一下，那我有没有写什么奇怪的？ OK， 有问题吗？可以 imagine 吗？这些geometry， 因为你一定要想象啊，你才可以算啊，不然的话你随便换 variable， 你会出错。你要想象你自己在换什么 variable， 要画得出来的这些 variable。OK， 我在想一下为什么我写 slice z 等于0啊？那时候。 that y plane, that y, and then we look at the x. Oh, okay, 我记得我在中里。Okay, so you know why I draw this? 那我在为什么我画这个嘛 ？Because when you decide for z and y, you need to tell me for all the zy, what is the x interval. So instead of doing for all, right, I just look at one slice first. I just look at the bottom slice. Okay, you can see that my s grow like this. Okay, but when the x, z, y go higher, right, the z will decrease. Okay, will decrease up to a point when you reach the top vertex. But who control this? Okay, the point is who control it. So it is controlled by the plane equation. So the plane will like cut for you. Okay, the plane will cut for you. Okay or not? 为什么我讲到这个 cut 的这个 idea? Let's say if all of these are just a constant number, what should you imagine this picture looks like? Let's say Z is going from 0 to 1, Y go from 0 to 1, X go to 0 to 1. What's the picture? What do you think? It's a cube. It's a unique cube. Okay, so all these variable here is trying to cut the cube into some shape. Okay, so you could imagine that you start with a cube, okay, and then you cut this way, cut that way, and then you get tetrahedron. Yeah, no. Okay, yeah, because you cut two direction in different function, so you kind of 你知道人家做雕像是怎样做的吗？做雕像是怎样做？木头不应该是长那样的，对不对？木头可能是长方形的，它不是长方形的，所以那个 cylinder shape，but they craft it， 它就是用不同的方式去切，它切出那个形状。所以是 you can think of it similar here. The basic shape is cube, and then you introduce different function as your bound, so you cut it in different way. So in this case, you cut it as a plane. Okay, in this way you cut it as a slanted line. Make sense? 那我在讲什么嘛？我在讲什么？如果全部这里都是 constant 罢了，它就是一个 cube 或者 cuboid。但是如果你用那个 function 去切它，它就开始把你整个 cuboid 左边跟右边或者上面下面都不一样的切法 ，depend on 你的 function。可以想象吗？这个 tetrahedron 是从一个 cube 切出来的，可以想象吗？看一下啊，我看一下啊，要讲变回 cube 啊，So well, I mean, if it is a cube， 你这边应该还有，那这边也是有嘛，对不对？还有一个角落在这边嘛，对不对？哦，原来在这里这样。你看你切掉多少东西啊？其实看得到吗？看得到吗？你看切掉蛮多东西啊，其实你的 cube 被你削掉一半，跟你说削掉一半，1/3啊，对，2/3比较 make sense。我知道你怎样想2/3，因为你还有一个，你应该要画这个东西出来。我知道你怎样想这个这样子。对呀 ，OK， 全部 shape 一定是从 cube 切出来的，因为3个 variable 全部放 constant 的话，就是一个 cube 或者一个 cube 过来的，全部 shape 都是从这里切出来的。OK，Does it make sense？ 看得到吗？红色是 cube 啊，我们剩下是里面的 tetrahedron。OK， 所以怎么切？用刚才那几个方式切。Yeah, thank you. Okay. Yeah. So basic shape is cube. You have to at least know cube. After cube, then we can slice it differently. 几点了？2点。Okay. So let's take a break. Yeah, let's take a break until 2:30. Okay. 啊 ？OK。方法丢还是随便丢，还是要丢够多，然后呢，根据家庭的这个程度。你的系统总是2:1的时候就好算，最容易算得出啊，最容易看到是3:1。如果不是2:1是怎么办？要丢进去那回合算过，我们算出来后面。 哦，有 formula 哦
我算出来了，那是
哦，所以那个比例是就是 proportional to pi。Yeah，
它是1/5拍这样子的，说是，等一下我看一下。对，那个 stick 要，如果那个 stick 的要子弹间距长度这样才比较好算。
OK，
然后你就会丢的时候就会看到就是刚才是丢出来的数量，就是你丢的数量跟香蕉的数量，拿香蕉的那数量除以
OK，香蕉数量 over 丢的数量
就是总数除以那
啊
个香
，OK
蕉数量
啊
就是
，OK OK，香蕉 OK 香蕉，
所以才刚刚是2跟1比的话，
嗯 要快讲修到几点了？13。OK。Okay, let's continue. There are a few more examples actually regarding these Houdini's thingy. I think we left it for next time. Yeah, for next time we start new stuff first, and then maybe in next class we can do some tutorial on that. You can try it also. We can do it in class later. But let's start new stuff. So in two variable, we can change rectangular coordinate to spherical. No, to polar. Okay, but in 3D, what do you think? What kind of shape you can feel 3D? And so in principle, you can fill it with circle or you can fill it with cylinder. Can you imagine that if you take different size of circle, different size of sphere, you can cover your R3. Is it true? Okay, so you must live on part of the sphere. Then if you fix a center here, or you can use cylinder to cover your R3. Can you cover cylinder? Use R3. Can you use cylinder to cover R3? 关门，iPhone 关门怎样？cylinder 是不是可以装 R3 一部分的东西，对不对？ But you can imagine you have a larger and larger milk powder thing. Then everything will stay inside this thing. Okay. Actually, you also can cover with other things. For example, ellipsoid also can. Ellipsoid 有什么 object 长得像 ellipsoid 呢？哎，什么？是咩？哦，好像是哦。哎，好像屁股比较肥一点哦。橄榄球哎，呀，橄榄球 ，rugby 啊，这叫 rugby 吗？好像是 rugby。OK。哦，obviously 你也可以用鸡蛋啊，也可以用鸡蛋去 cover 我们的space 啊。But can you parameterize your egg or not? Okay, can you parameterize your egg? So for cylinder, for spherical, We can do it. Okay, we can do it. Let's do it. Let's do it. Where is it? Let's do it on one go and then we'll discuss how to integrate over this. So let's look at this cylindrical coordinate here. So first we fill the whole R3 with infinite cylinder centered at the origin. So how to imagine cylinder from a polar coordinate? So if you just look at polar coordinate, you have circle. But how to form cylinder? You just put a bunch of circle together. Correct or not? Fill the top, fill the bottom, and then you will get a cylinder here. So in this case, what's the change of variable here? So the change of variable is similar to what you know from polar. So in x, you have r cos theta. In y direction, you have r sin theta. Okay, let me draw it out. X. Direction, y direction here. So you have radius r and theta. Okay, so x equals to r cos theta. Then y equals to r sin theta. And then how about your z direction? Okay, how to do the z direction here? So in z direction, you just take z equals to z. Okay, so meaning you just put bunch of circle, okay, in different height. Then you will form your cylinder. 对吗 ？cylinder 是不是那样子 form 出来的？是一大堆的 circle 放在一起。Okay, so meaning how you imagine R3 in this setting? 什么？ Okay, and then yeah. Okay, kind of because it's a radius, same radius, right? Okay, I mean what I want to say is how to imagine cylindrical coordinate from polar coordinate. I mean how to imagine R3 in terms of R2 in this case. You just place a bunch of R2, infinite sheets of R2 together. Okay, 懂什么意思吗？ Do you get what I say? So you start with R2, right? Okay, so because R2 can fill with infinite cylinder here, infinite circle here, then what do? You can stack infinite sheets of R2 together. Okay, yeah. 有点像那个蚊子的那个哈，蚊油哈，蚊香。Okay, you put them together. Then you form R3. And then if you join this circle together, it's the cylinder. Okay, so to go from polar coordinate to cylindrical coordinate, you really keep your x and y substitution, but z is the usual z. Okay. Okay, so this is a cylindrical coordinate. This is kind of boring. Can we skip this one? You can do it yourself. It's a free variable version. Just use this substitution. So what's the generalization here? Really, we just add a z direction to our polar coordinate. Okay, so not much. But spherical is interesting. Okay, spherical is interesting. So let's look at spherical here. So if you look at spherical case, what do? This is not something coming from polar coordinate anymore. Okay, so this is like really built into R3. Okay, because sphere only exists in R3. Okay, so we try to fill our space using different ball or size of different ball. Okay, it's like how we fill R2 with different size of circle. Okay, now in this case it's a sphere. So how do we do this substitution here? So let's go back here. Maybe this picture is easier to understand. Right, so you will see that so many sine cos, but there are really two angles to remember here. One is called a theta, one is called phi. There are names for them. I forgot. One of them is called azimuth. Azimuth. But you can find out. But now let's call it phi and theta. Okay. So what is phi and theta? So the relative position is important. Relative position is important. So we still have the polar angle here called theta. It's the same one. Okay, with the polar coordinate, it's the same, starting from positive x-axis. But now we have an extra angle, call it phi. Okay, so this phi here is coming from positive z-axis. Okay, coming from positive z-axis. So we can try to use these two variables here to describe three coordinates. Okay, three coordinates. Is it enough or not? Using two variables to describe three coordinates here, is it enough? Enough or not? Enough. Only two bases. So you need one more. What's the other basis you need? The radius of your sphere. Okay, you still need rho here. Okay, we call it rho in this case. Right. So, well, I mean, if you treat this as a r, right? Xy here is just again the polar coordinate. Okay, but the r here looks a bit different. It's controlled by rho and phi. Okay, so what's this rho and phi doing here? Actually, this is related to your height. How you get your height from phi and rho. Okay, how you get your height. So the height here says you have to take the radius of the sphere and then time cos. What does it mean? Cos is a ratio of what? Adjacent over hypotenuse. Okay, so there's a right angle triangle here. So let's draw the right angle triangle first. And then where's the phi? Let's say phi is here. So adjacent over hypotenuse. Okay. So, well, where's the right angle triangle in this case? So just now I told you that phi is an angle coming from positive z-axis. Okay, so you should form a right angle triangle here. Okay, going from z-axis to this point, particular point here. And then what is z? Z is adjacent time over hypotenuse. So adjacent is actually the height in z. Okay, and hypotenuse is the radius. So what's radius is this? So we are implying that this P is living on a certain sphere centered at 0. Okay or not? So the idea of spherical coordinate is every point should live on some sphere. Okay, with a radius. Okay, we call it rho here. Okay, so does it compute the height or not? Do you agree it computes the height here? It represents the height of this point P. Do you agree or not? If you take rho times cos phi, do you agree? It represents the height of P. 你懂我讲什么吗？这懂我讲什么吗？还在？我讲吗？
就是那个
嗯哼，
有
嗯哼，嗯哼，
这样子来报咯。
I mean，你同意吗？它 represent 那个 P 的高度，为什么？
因为这就是它的高度。我在比他什么
随便，你觉得为什么你同意啊？
？cos phi 的，是 z 除以那个肉除以这个。
But cos phi is the adjacent edge divided by the hypotenuse. So well, I mean, when you form this right angle triangle, right? Is this how you get the height of P? 你是这样拿 P 的高度吗？你去量高度的时候啊，去 clinic 啊，他怎样量啊？他去拿 clinic 的时候怎样量？你去 clinic 的时候，他怎样量你的高度啊？怎样量你的高度？是不是要这样直直的伸过去？是吧？是这样子量吗？不是这样量你的高度，要90对不对 ？Then this is the line that measure the height of P. Okay, yeah. So if you make a perpendicular angle to this z-axis, okay, so you will form this exact right angle triangle here. So the adjacent edges to phi is the height of P. Okay, make sense 吗？对吗？ Does it make sense? Okay. Well, okay, good. So, right. So what is the phi sine rho sine phi business here? What's this business here? Rho sine phi. What does this do? Sine compute what? Opposite over hypotenuse. So what's the opposite here? So here is A, here is opposite, here is hypotenuse. So actually it is compute the radius. Radius from origin when you project orthogonally to the xy plane. 对吗？是吧？是这个意思吗？看得出吗？能不能看得出吗？ If you project orthogonally into xy plane, what's the distance here? This is exactly the opposite of cos phi. Sorry, phi, the angle phi. 对吗？想象得出吗？还是把它画直一点比较好看。So let me draw like this. So here is P, right? And then here is phi. And then how do you find the point P prime, which is the orthogonal projection of P? Okay, so this pi is exactly sine phi time. So let's say this radius called rho. Okay. Does it make sense? Okay, ma. Any question? Anyone confused? 问吧，有问题的，问吧。啊，讲多一次，从哪里？青色的哈。Okay, so if you look at this P here, and then you want to try and do orthogonal projection, if you just look at this plane here, so what's this plane? This is a Z of P prime plane here. So if you do the orthogonal projection, how do you compute the distance from origin to P prime? How do you compute this? Given that you know phi, okay, given that you know rho, you simply just take rho sine phi, because rho sine phi is opposite over hypotenuse. So this length here is actually the opposite edge of phi. Okay, yeah, and then you should use this length to tell you what? Tell you the position in xy plane. Okay, you use this radius to tell you the position in the xy plane. How to tell? You need to tell me which point in the circle of radius rho sine phi that P prime live in. So you just tell me this angle. Okay, so that's why you have sine theta cos theta. Okay, so the front part here is the radius that you project down from R3. Okay. Remember, so in R2 you don't need to project because you already live on R2. But if you need to talk about any point in R3, you need to project down first, orthogonally project down, and then you tell me which circle. So in other words, how to think about spherical coordinates? You start with xy plane, okay? You start with any circle you live in, and then you tell me the height, how to go up, how high is this point, okay, or how low is this point, okay? Then you need to use this phi angle to tell me. Okay. 有问题吗？ Maybe you can do experiment. I can also use angle from y, right? 也是可以啊。Then you need to change your substitution, and maybe you need to change your domain also. Okay, so let me ask you, if I change to rho phi theta, where should this rho phi theta live in to control to like reach every point in R3? So what is the domain that we need to take for rho phi and theta to get the whole R3? What do you think? Oh. 要答写法没啊？你看到不用紧，不止一个答案。 不止一个答案 actually. So let's give me one answer first. Right? 什么 Try. Roll everything greater than 0, okay. And then find this direction, how you fix 0 to pi. So 0 to pi means what? You will cover up from positive z-axis out to negative z-axis. And then how to reach everything. So this one is just one slice, right? One plane. So how to reach everything? You need to take 0 to 2. Okay. Let's say, I don't want to take from 0 to pi or 5. Can I take to 2 pi or not? Or I cover everything back. Okay. Then on the other side, on the other side, theta 是小点. How much is enough? Okay, pi. Because you, instead of half this, right, you got a full this. So if you twist 2 at the same time, then you just need to twist half round is enough. Understand? Can you imagine? Okay, can you imagine? 大家想得到吗？它没有什么圆的东西哦。我想想。Okay, one way is you do it like this, right? So you fix this axis, right? And then you turn around. This is the first way. Second way, you do like this, and then you take in the middle, and then you do like this. Okay. So you need to do half only, no need to do twice. Okay, but for this one, you need to do whole twist. Right. But for this one, you just need to twist half of it. Then you can feel both hands. Okay, makes sense. Okay. Okay. Good. Yeah, I think these are easy to check. So let's see what to do. To do one exercise. Let's see. Maybe we do one exercise on spherical coordinates. That one is a bit trickier. So let's try this. So let's try this question here. So if I gave you spherical coordinate, can you find the rectangular coordinate or not? So meaning you want to find the x, y, z. So what's the formula here? Let's be it. So x equals to rho sine phi cos theta, and then y equals to rho sine phi sine theta, and then z equals to rho cos phi. Right, so spherical coordinate, how do we write it down? So what's the order here? So the order here is rho, and then theta, and then phi. Okay. Okay, try and plug this value. Convince to yourself that this formula works. Then convince to yourself that this formula works. Try and compute what point of x, y, z is this. Okay, anyone computed what x, y, and z? 0.6/4. Is it? Everyone computed 4. How about next one? Same. Hey, why I compute 2, 1, 2 or 4? Right, check. How about that? 1, 4. You get 4 or get 2? I also get 2. Everyone try and check. Should be 2, eh? √6/2. Try and check. Should be 0. 有算错吗？怎么算错？怎么算错？把 row 当成1啊 ？Okay. Then it's fine. Okay, so can you check that it live in the same quadrant? 这是不是 quadrant 吧？ This is called octane because you split your space into 8 parts. And does it live on the first octane or not? 对吗？是不是在 first octane 上面 ？Positive x, positive y 跟 positive z. Okay, so it's the right direction. Okay, yeah. Okay, good. So maybe you ask why 这么麻烦的搞这种东西 ？Actually, spherical coordinate is quite useful. You can even draw a plane. You can draw something in a rectangular coordinate. Okay, obviously, first you can draw a sphere. How to draw a sphere? You just keep your rho constant. But how to get the plane here? You keep your theta constant, actually. You can draw a plane. Okay, but you note that this plane is a half plane. Because why? Because by convention, they are phi from 0 to pi. Okay, that's the usual convention. We use in this class also, although you can change it. And also, you can get these cone shape. Let's look at this cone shape. Okay, so how to get this cone shape here? You just fix your phi from 0 to some angle. Fix your phi from 0 to some angle here. Can you imagine that how you get this cone here? Because you include all the point that has angle phi in between this. Yeah. So this is a fill up cone actually. Cone. So it's a fill up cone. Everything from 0 up to pi over 2, but not equal. I think we need to like 这样子，是全部在里面的东西。Because there's no restriction on theta, there's no restriction on rho also. OK 吗？只要是这一个 phi 的 angle, we take it. Okay, there's no restriction on theta and rho. So that's why we include everything 0 to 2 pi in theta. And then I include every radius. Where we include every radius. OK 吗 ？OK， 这个应该不可以等于，因为不然的话就平掉了。对啊 ，OK。So 它可以是0吗？哈，我想一想。哦，这个 C 就是说它要包含全部罢了，是吗？它的意思。Yeah, but I mean, I mean 这个也比较好吧，这个比较好，应该有包含0。
0的话就平了。
有0的话是那条 Z axis， 所以 if you take out Z axis， then 这个 cone 就被你插一个洞下去了。来，我一定对。哦，我知道了，不然的话 Z 等于0会加对面的东西，
加多一个。
给我想一下，就是对吧？不太对，应该不太对，应该就是 positive 吧。I think this one is better. Okay, not taking out the positive Z axis. Okay. Yeah. If it is after pi over 2, then you will go beyond xy plane. So that's why you take that. Because already go beyond xy plane already. OK， 有问题吗？那个等于派或等于0，什么情况啊？所以我们可以算一下，其实cos 0是还是等于 有什么问题啊？啊？什么？你刚才要问什么？你刚才要问什么？你说这个啊？然后
可以。就我这条。
你说I mean, if you want to form this half cone, obviously you should include the axis, right?
因为它不是心啊，是讲那个词对什么？是讲
哦，right.
借一下时间，它就会生。
That makes sense also. Yeah, that makes sense. I was trying to fill this cone in. Yeah, I get it. That makes sense. So meaning if you fix one C, right, and then that is the real cone. But when C equals to 0 is a this. Maybe we call it a degenerate corner. 就是那个 cone 被你压去一个点了，还有压去一条线，压去一条线。degenerate cone，跟 degenerate 全部 cone 的点被你压去一条线。OK。哦、that makes sense. I think that make more sense. 我就在想这个东西要不要填进去。
要不然太 O2 的话，它应该上面整个面都是。
Sure，那有问题吗？O2 就是wait, O2 is just XY plane, right?
上面整个全部都是啊。
没有上面吧，它就是 XY plane 了，它被开掉了，它 con 被开掉了 ，right? Just XY plane, right? Pi over 2，那个 con 被你开下来，对不对？就是整个 XY plane，但是 XY plane 被折上来的时候，它就是一个 OK。可以想象吗？可以想象吗？这一课一定要想象啊！你没有想象哦，很难哦。你要 variable 乱换会换错的。OK，所以一定要想象它。OK，现在还有什么我们要做？Maybe 我们看多一点 shape，要帮你看多一点 shape。Okay, well, I mean, any question? Maybe we can take a break from here. Later we'll do integration in these two coordinates. 有问题吗？想想这些点，用 sphere 跟 cylinder。If not, later we will see example how to integrate in these coordinates. Okay, what is the Jacobian you will see in this case, and then yeah, what sort of shape is favor over what coordinate? Okay. Yeah, let's break until 253.
你可以探讨到这个地方，可是。可是我会看班学套，这个很差的好之前，真的就是一直在这个案件，结果这不是前面好，是这个样子的吗？还有上一个人最高的到多少多高？多少倍高？再高了，高过那个最之前。那个刚好一点，不结婚。哦，是往前。现在应该是在偏成功的事情，因为有点挺很复杂。
叫什么？
反过
哦，什么墨？哦，dry。哦，嗯，
没有，拿个是来的一些不用，不这个哦，是那一个，
哎，Humble，你早上没有在是吗？哦，为什么？子英啊，关于你问的那个 set point 不是那 set point 其实它是一个 critical not stationary point，but 它不是 local maximum，也不是 local minimum。对，它其实不一定要长得像 set 这样。其实你可以 imagine 呢，in one variable case 啊，你不是 maximum，不是 minimum，还有 first derivative 等于零的是什么？我们叫 inflection point。假设那个 inflection 就是比如说 y 不是 x cube 啊，那个 x cube，它中间的点就是 f(x) 等于零的时候，sorry f prime x 等于零的时候，and then 如果你拿这个 x cube 啊 form 一个 plane，那个点也是那些点也是一个 set point 来的那些。呀，所以它不一定长的是两边上去，两边下来，不一定。它就是一个不是 local max，也不是 local min，但是它的敌人一直零。但是什么情况会拿到敌人这零？就是下来的时候它 approach 零，上去的时候 approach 零，这样不一定要两边上去或者两边下来 approach 零，它可以一边下一边上，或者它可以四边这样。Anyway 啦，but I mean，yeah，so center point。所以那个情况是 d 小于零的话，它就是一个 set point，对不对？我找到一个 proof 啊，我找到一个 proof，它是用 multivariable 的 Taylor series 来看，multivariable Taylor series 不是很难，但是可能 proof 就可能有点难吧，怎么拿到它？但是如果你 assume 你拿得到它的话，那你就可以去看一个计算哦，看什么计算呢？看second derivative 的计算。in different direction. So d square in any u. OK，说、如果 d square in any u 是大于零或者小于零，它就 imply concave outward or downward。那 in 这个 case，如果 d 小于零的话，那个东西就有大有是小。我可以 send 那个 document 给你看。呀呀呀呀，说如果有人有兴趣，我可以 send 给他。他这个我找到他是用到two variable 的 Taylor series。因为它要算那个 d square u。OK， all right. So let's come back. So we will try and compute triple integral in the cylinder coordinate and also in the uh, spherical coordinate. Okay, so what sort of domain we're interested in? So let's say we start with cylindrical coordinate. So cylindrical coordinate, how to think about cylindrical coordinate? It is just a bunch of polar coordinates put together. Okay, so you should imagine that in cylindrical coordinates, we have just an extra r there. Okay, with just an extra arm there. It's the same as polar coordinate because in the z direction, you didn't really do any substitution there. You just add in an extra z. Z equals to that. Okay, you just add in an extra height there. And what sort of domain you could see? So you should imagine that you have the polar rectangle, just increase in height. Okay, so you should imagine your pizza has a depth. 你的 pizza 现在 order 的是厚的，有名字不是？我忘记了我名啊。厚底的 pizza 叫什么 ？pan 呐，确实好像有一个叫 pan 什么东西。薄底的叫什么 crust 啊？薄底的是 crust， 厚底的嘞 pan 哦什么？很久没有吃了，忘记了。But okay, so you should imagine that your pizza slice has a dz height here. Okay, dz height. Okay, so let's try this. Can we? Okay, let's see. Is this the right exercise? Okay, I think this is the right exercise. All right. So can you see this as a cylindrical rectangle? In this case. 可以吗？如果可以的话，我们先 try 先，然后我们 let's try 啊 ，let's try. Let's write down the domain first. Okay, no, remember, this is just domain picture, not the hypervolume picture. You cannot draw it because this is a triple integral here. So we can really just draw the domain. We cannot draw the volume or the hypervolume. Okay, R4 we cannot draw. So this is just a domain picture. So what's the domain here? Read from this integral here. So this integral go from where to where? So x, y, z in R3. So who get control here? So z get control from square root x squared plus y squared 2, and y control from 4 minus x squared minus 4 minus x squared to 4 minus x squared, and then x going from -2 to 2. Okay, so is this possible to be a part of cylinder or not? So if it is part of cylinder, what do you need here? So let's try. I'm also not sure. Let's try. So we have rho, theta, and z. Can you use rho, theta, and z to build this shape or not? Let's think about it. If I just give you this, try if you can draw this out or not. Okay, so you should start with x. So x from -2 to 2, and then you build your y. So can you see that this y is bounded below by some circle, part of circle, and then bounded above by the other part of the circle? Can see or not? 看得到吗？还是 upper circle and lower circle here? So you will get this circle at the bottom. But how to get this height? How to get this height here? So z will tell you, give me an xy, I tell you the height. Okay, give me an xy, I tell you the height. For example, what? Look at the point at the origin, 0, 0. Okay? If you put 0, 0 in, what's the z interval here? Going from 0 to 2. So on the origin here, you have the full interval from 0 to 2. But you imagine when you spread out from the origin, what happens? What is this? This term here is just the radius of your xy point. Correct? R square equals to x squared plus y squared. So r equals to square root of xy. So meaning what? When you split out far from origin, the lower bound get higher. Okay, the lower bound get higher, but the upper bound is the same. So that's why this is a flat surface. Okay, on the domain here. Okay, but how do you know that whether it is how do you know whether it is a linear or not? Linear cone or maybe curved cone, right? Part of the circle. How do you know it's linear? No, it's linear. Sorry?
X x pen 在 X plane 来看，这个 ZY plane。
ZY plane. Oh, sure, yeah, sure. So you can, for example, look at the ZY plane. You made X equals to 0. Okay, so if you make X equals 0, you are just going from Y to 2. Okay, so you increase in Y. Okay, linearly. Okay, or like what I told you last time, right? You can what? You can look at the directional derivative. Okay, it's the same. You look at the slice and look at the directional derivative, it's the same. Okay, so if you look at the directional derivative, right, you should compute a constant. Okay, in any direction, you should compute a constant. I mean, you know what am I talking about? Directional derivative on this surface here, you should see a constant. Okay, what's this surface? This surface is the lower bound of your Z. 明白吗? Okay, so if you do this, let me write here. If you do directional derivative in any direction, so we call it du, right? On this x squared plus y squared, I'm sure you will get a constant here. Okay, I'm pretty sure you get a constant. Should go and try it out. Or like what Yixiang say, if you fix, let's say, just fix zy plane, meaning x equals 0, z is just equal to y. Okay? Z equals to y. Okay, so if you fix, sorry, absolute value of y. Square y squared. Oh yeah, sure. So you will get this y, and then on the other side minus y. Okay, so you get both sides. Okay, no. Okay, so if you look at the zy plane here, so zy plane, intersection of zy plane with your surface. Okay. Yeah. You can use the direction derivative way to do it, or you can use the substitution way to see. Substitution. So in this class, whenever you do substitution, it means what? Substitution means what? Substitution means what? Every time when you substitute a variable, before 将为 intersection of two objects. Okay, intersection of two geometric objects. Okay, intersection between two planes or two surfaces or plane and line or something like that. Okay, depend on what you substitute. Okay, after intersection, you will get a object that's reduced in dimension. Okay, is it clear? So substitution 不是只是号码换一换呢 ，is an intersection between two geometric objects. Okay. Yeah. Right. Let's come back. So can we use the cylindrical coordinate to explain this column? What do you think? Okay, first of all, theta. Is it clear that theta where you want to take? Theta. Cone, right? So what kind of theta you should take? 0 to 2 pi. Okay. How about radius? In this case, how big is your radius, the cone? Radius going from where to where? 0 to 2. So radius is 0. Okay, so now the problem is Z here. How to decide this Z? Okay, let us try some experiment here. So if I fix Z to be 0 to let's say 2, do you know what this shape is? What this shape is? You got the full angle, and then you got the radius, and then you put on your height. So what is that? You get a radius. You got a radius. What do you get? Cylinder, right? Okay. So well, you should get a cylinder like this. But you can see that here is like a cut off cylinder here. So how to cut off this cylinder? How to cut the bottom part out? Bottom part controlled by what? A surface, right? What's that surface? What's this surface? Here, right? Square root x squared plus y squared. Okay, square root y squared plus x squared. On the other side is 2. But 你不觉得有点突兀吗？又有 x 又有 y 又有 theta 又有 rho 又有 z， 5个 variable 啊。So you can try to change variable. So what variable you can change here? So this is literally rho, correct? No? That's the radius. Okay. So meaning what? So how do you cut off your cylinder? You just use the radius of your point. Okay. So where you stay. Okay, where you stand. You use the radius to cut off your. Okay. Okay. Any question so far? Any question? No? Okay. Okay. So just now in rectangular coordinate, the basic shape is box. But in spherical coordinate, the basic shape is what? What's the basic shape? In rectangular coordinate, the basic shape is a box. So in cylindrical coordinate, the basic shape is cylinder. There is a cylinder. So everything will be cut off from a cylinder. So 你是用一个 cylinder 把它切出来的这种。In spherical, the basic shape is triangle, and then anything that you can cut from the sphere, then you can do this integration here. All right. So can you see that once we change the set of variable here, our integration domain become easier. 知道为什么 easier 吗？你看有好多个都是 only bounded by scalar。Okay, scalar 东西就很好算，不然你就有很多 variable 要去照顾了。Okay, for example, in the case above, you have what? Y depend on x, and then you have z depend on x and y. But in the cylindrical format, what is depend on what? Only z is depend on rho. Okay, that's the only dependent. The other is just usual partial integration. Okay, so let's write this down so we can change the integral, the complicated integral here. Into cylindrical form. The cylindrical form to let's say dz, dr, d theta. Why we want to integrate over dz first? Because z is dependent on the rest. Okay, in particular rho here. So let's put z. Z is from rho to 2. Okay, and then we do dr. So r here is rho. Let's put rho here. So rho from 0 to 2, and then theta from 0 to 2. Okay. Yeah. Okay. So when we change these coordinates, there's an extra factor rho. Okay, similar to the polar coordinates. And x squared plus y squared is just rho squared. Okay, rho squared. Okay, so you just if you integrate this, you should get 16 over 5. Right? How about, can you change this to a spherical coordinate or not? What do you think? Can you change this to spherical coordinate? So this one, you can go back and compute yourself. Besides this. Okay, so let's see, we can try compute to spherical or not. Can we make this a cone out of a sphere? Then my question is, what do you need for sphere? You need rho, theta, and what? And phi. Okay. So theta is the same. Okay, theta is the same. You should use the whole theta from 0 to 2 pi. But how about radius? Is radius easier to see? Or phi easier to see here? What do you think? Which one is easier to see? I think phi is easier to see, right? Phi control what? Phi is the angle from where to where? positive z-axis to so phi is the angle starting from positive z-axis. So can you see that there's a fixed angle coming from positive z-axis here? So meaning you want to ask, what's the angle it forms between z-axis and this surface here? Do you know how to find it? 会不会找这个 phi 啊？找得到吗？你觉得？恩慈有办法吗？好 ，how to find phi 啊？来 try 看。I tell you the surface already. Okay, can you find this phi? 很找吧。来凯伦了吗？想找这个 phi。Sorry， 想找这个 phi。四分之派怎么找？哪个？对 ，slowly 啊，slowly。So cosine phi equals to z is what? Z. Okay, z adjacent嘛 right? So you form a right angle triangle here. Okay, z over this row. So square root x squared plus y squared. So how do you compute a useful phi here? Do you fix some z or fix some point on the surface or not? Z over square root x squared plus y squared 什么东西啊？ You have a row also can you change your variable, huh? Okay, you also can change your variable, sure. Then 又怎么样？怎么样？哎，全部人要想啊，不是一想的工作吧？全部人都要想。how to find phi? Can you see that this phi is constant? 看得到吗？因为它是 con 嘛。But how to find this angle? How to find this angle? 找啊，哎，这其实是高中题啊。啊，找 angle 嘛，对不对？我已经画那个 right angle triangle 给你了。Okay, try slowly. So start from where? Okay, so this side is 2, cool, good. And then the radius, the radius of the upper, this. How to find this? How do you decide this two here? How to decide? Very important. Okay. 一点乖乖。I mean, you should look at the intersection between z equals to 2 and your surface, right? Correct or not? You should look at the intersection between z equals to 2 plane with your surface. Okay, so in that case means what? This circle is a radius. Radius 2. Okay, because if I reduce the height, this radius will reduce also. Okay, it's dependent on your height. Okay, it's not dependent on your domain. Okay, so this is 2. So is it enough now to find phi? Is this enough? Fine. So what tangent or cos or sine you want to use? Tangent, huh? So if you use tangent phi, which is opposite over adjacent. So 2 over 2. So tangent of 1 is what? Pi over 4. Okay. I think there are a few numbers. There are a few numbers, but pi over 4 is used in this case. Okay. Hey, sorry, this is fine. Okay. How about radius? Radius? So meaning what? You already settle. What have you settled? You settle theta, you settle phi. How to settle this flat surface thing? Huh? Is it just rho? So if I put rho from where to where? Obviously from 0 lah, because you need to start from origin. But what's the upper bound here? Can you put 2 or not? If you put 2, what's the picture? What's the picture if you put 2? There's a dome up here. Okay, but you don't want that dome, you want flat. So how to make it flat? How to cut it? How to cut it? How to cut? Wow. 其他指的是 okay, so 2 square root 2 like this. But what is this? 0 up to 2 square root 2. So you will circle out a dome here. But you want flat. You get what I mean? So meaning what? If you fix the theta, fix the phi, you can see that the height is different actually. Okay, it's not the same length from different direction. It's different length. Can you see what am I trying to say? You can see that at the origin, the height is the longest. Okay, but on the other side, it gets shorter and shorter, shorter, shorter. So how to describe this? How to describe? Think. How to describe? 想一想。How do you describe the top part? How do you describe that part? That part in the XYZ plane, what is it called? 叫什么这个 plane? 这个 plane 叫什么 ？Z equal 几 ？2. But how do you change from Z to a spherical coordinate? Z equals to rho cos theta. So this is the plane you need. Rho cos theta equals to 2. Okay, so what's your upper bound here? Your upper bound is 2. 2. Sorry, not theta, it's phi, right? Okay, so it's just 2 over cos phi. 明白吗？可以看到吗？这个 2 over cos phi 真的会变。当你的 phi 越来越大的时候，你的什么？你的 rho 越来越大，大还是小？大。OK， 大还是小？So when phi is 0, phi is 0, cos theta is 1. So 2 over 1 is 2. Okay, so at the point 0 is 0 to 2, correct? And then what else? 哪里反？有反吗？没有反吧？应该没有反，没有反。有反吗？对不对？应该没有反吧？想一下有错吗？check 一下有没有错。 什么叫另外一个 method？ 现在有没有错？现在有没有错？现在有没有错？One way to check, right? If you a bit skeptical, go and compute this in terms of spherical coordinate. See, you get the same answer 了。讲一下，应该没有错吧？从这边 and then 下来 ，and then radius is going from 0 to this. Yeah, I think 没有错。I think 没有错。That guy is torsion. Okay, never mind. OK 吗？有问题吗？这个可以 imagine 吗？可以想象吗？Well, I mean, if you fix a feet, it will tell you the radius from 0 to this point. 想象应该对咯，对吗？因为它是越来越短的。因为 if you go from here， 越来越长还是越来越短？越来越长还是短？长哦，越来越长。So actually, this line is longer than this line. 对，我觉得对，我觉得对，因为 correct or not? Hello，因为okay, so let me draw something here. So I wanted to compare the length between the origin to this line here and this origin to the other point on this line. Should be longer, right? 对吗? So let's call this R1 and then call this R2. So R2 should be greater than R1. You agree or not? 对吗?对哈. So if you change 5, this number here will become larger. Okay. Yeah. So 意思说什么？意思说什么？意思说 if I put 2 here, what is the shape? The shape should be going like this. Okay, if I put a constant 2 instead of 2 over cos 5, the sphere should look like this. 看到吗？这个 ice cream 应该要长这样。Okay. So understand? So 其实被 extend 了，如果我们换的话，其实不是被切掉，是被 extend 掉。对吗？有问题吗？没问题。Okay, yeah. I think this way is better to think about it. 所以其实我们是很 free 的，你要用什么都可以 as long as it works. But you should imagine if I substitute this in terms of spherical coordinate, how does it look like? You'll see a lot of things like this together. Okay, so you need to. Oh, I haven't tell you right. We haven't really introduced the Jacobian for spherical. So let's introduce the Jacobian for spherical. So instead of R in Jacobian, you will get R squared sine phi. Okay, R squared sine phi. Okay, extra rho and extra sine phi here. Okay, popping up. Why is it popping up? Later when we do general Jacobian, I'll tell you why. All right. In that case, let's try one example. Try this example. Is this fun to play? Let's see. Okay, I'll just try this. So this is kind of review because this is already a ball. Okay, so you should use spherical. So if you use spherical here, what's the radius of this ball? What's the theta? What's the phi you are using? You are really using everything, right? So let's turn this into rho, theta, and phi. So since this is a full ball, you should take the whole radius here going from 0 to 1. And then obviously you need to take your theta from 0 to 2 pi to cover the whole ball. And then your phi is the standard domain from 0 to pi. Okay, and then you do this computation. You want to try to compute this? You want to try to compute this? See if you can get good answer or not. Try to compute this, see if you can get something useful. Or maybe I write some intermediate step for you to check. Or what's the intermediate step? Okay, in this case, really, you can split them up because they are just product of function in different variable, so you can split them up. OK，有吗？算完了，算了，后面人，你们算哪里了？我算什么啊？我只是把那个 variable 替换一下 ，and then 有一个 extra row square sin phi，then 你要分哦。So I split into three iterated integral, not iterated, but partial integral here, because they are product of function in different variables, so we can compute at one go. Okay, so in the end, you should get 4/3 times e minus 1 pi. 算得到吗？还是还要第一步先 ？Maybe I write down the first step. So what's the first step here? So you do it e row d theta d phi, and then you have extra condition phi square and sin phi here. Instead of row, you have row square sin phi. Sorry. 有吗？有拿到吗？有拿到吗？虽然你看到怎么这样奇怪，有3/2在那边呢，其实它是要 cancel 掉 row 的 square。OK，cancel 掉 row 的 square，你就会看到一些 integration by substitution。有吗？有算到吗？大家 check 一下。有吗？我写的这个 intermediate step 看起来会对吗？有吗？还 start 吗？start 在哪里？start 在哪里？有 start 吗？有算到吗？还是哪里 start 对？OK，来算，算完了吗？还在算？ 还有卡住吗？ Oh, they are having a master defense now. No wonder they are passing by. 3:30. The defense next door. 说完了吗 ？OK 吗？有算到吗？还是有卡吗？有卡吗 ？Feel free 呀、问罢了啊，如果有卡的话 ，we can help you unstuck now。你在家没有人帮你 unstuck，这里有人帮你。OK 吗？全部有算到吗？要算啊。OK，回家我是陪不了你算了嘛。OK，OK 啊，OK，let's continue。What time is it? Let's go to new stuff, and then in the next class, we will review all these again through exercises. Then we will do again. But let's go to new concept first. So I guess this is the last concept we'll touch today, which is the change of variable in multiple integral. So this is the place I want to introduce the Jacobian to you. Okay, so let's look at this. So let's do it for double integral first. Suppose T is a one-to-one transformation from R2 to R2. So what's the one-to-one transformation here? So this transformation, you should think of it as a, should it be linear? I think it's non-linear. Yes, it's non-linear as long as it's one-to-one. Okay, one-to-one just mean injective. Okay, so you cannot send 2 points to 1 point. Otherwise, you distort your space. Okay, so it must be one-to-one transformation from UV plane, okay, to XY plane. So if you look at this, this equation here, looks very familiar. So when you try to integrate over xy, you change it to some variable in u and v. For example, what you did just now, polar coordinate. Your u and v is what? R and theta in that case. Okay, so for example here, let's put an example. Example, your u and v is R and theta. Okay, your u and v is sin theta. So what's the linear transformation in this case? So how do you send r and theta to xy? What do you do? What's the formula you take? You let x equals to what? X equals to r cos theta, and then y is r sine theta. Okay. So whenever you do this kind of change of variable, you are imagining a linear transformation from r theta to xy. And this is what you should imagine from r theta to xy. But in this case here, if you prove this theorem, there will be some extra product you need to take, which is the absolute value of Jacobian here. Okay, so this absolute value here is what? Is your determinant actually. Okay, why is it a determinant? So what is JUV here? JUV is this Jacobian. What's this Jacobian? So you arrange your domain variable in row, in the order of row, in the order of column, in the order of column. So you put x at the first row and then y at the second row, and then you arrange your u and v in column or in row. In what do you think? In column. Okay. Yeah, in column. Okay. Does it matter? Do you think? Does it matter if you sort? Does it matter? If you sort the order, does it matter? For this determinant? Does it matter? Yeah, become minus of. But okay, so actually this Jacobian are already taking determinant, but you are taking absolute value of Jacobian. Okay, so don't care actually. Actually don't care one. Okay, even though if you swap the order, you just take the absolute value of it. Okay, actually don't care. Do you know that if you swap the order, your determinant will change sign? Do you know? It will change sign if you swap the order. But it doesn't matter because in the formula we take absolute value of it. Okay, so the sign change is okay. We'll take absolute value. Okay. Right. So do you want to try and compute what is the Jacobian of the polar coordinate that we did just now? You want to try? Right? Compute. Try and say what's the Jacobian for r and theta? So I'll try and compute J r theta. 来算一下这个。Try and compute this. What is J r theta here? So basically what you do, you just collect all the different partial derivatives together. And okay, can compute or not? What's the term in the 4 spot of the matrix? What's the term? Can you tell me? What's the 4 terms here? Cos theta minus r sin theta. Sin theta. And then r cos theta. Okay. So if you compute this, do you get r? Is it r? Okay, so this is how you get your r in the polar coordinate integration there. Okay, everyone get r? 有吗？有拿到 r 吗？有吗？ Okay, okay. Right. So what's the significance of this r? So what should you imagine here? Excuse me. What should you imagine here? So you take r theta. Okay, so you should imagine this as r theta rectangle here. But when you put it on xy plane, this rectangle kind of stretch. It's very stretch. Do you still remember the polar rectangle or not? It looks something like this, right, in xy plane. So you kind of stretch your rectangle. Very stretch by a factor of r. Okay. Does it make sense? Okay, so but you are using the stretch rectangle to compute your integral. Okay, so that's why it incurs a factor here, because your original rectangle get stretched. Okay. 看得出 stretch 吗？看得出吗？看得出这块布好像被拉长了，本来是一个正方形啊，然后被拉长，被 stretch. Okay, so there's a factor of r here. But the former proof is here. You can go back and have a look. But I won't test on it. If you are interested, you can see. Okay. So well, 有问题吗？问题吗？ Okay. So let's try these examples. 看一下这个 example 我有。我们要不要做这个？ Okay, let's look at this example here. So this is a different transformation here. 几点了？看一下，要不要做这个？还是做另外一个比较好？让我看看。好吧，做这个。All right, so let's look at this one. So evaluate this function dA with vertexes 0, 0, pi, minus pi, and pi, pi. So actually the domain is this one. So this is the domain. Okay, so this is the domain. So what's the technique I teach you in the morning? So this is a continuous function on a general region. What do? You can use fu bini. Okay, either dx dy or dy dx on. Okay, so you should determine your region. Okay, the bound, upper bound and lower bound. But do you know how to integrate cos minus y or not? X minus y or not? 会不会? Let's say we already decide integration domain. Okay, like this, for example. Can you integrate cos sine minus y and sine plus y, even if y is constant? 会吗？会做吗？难做。by part 啊？对吧？我不确定。You can try. Okay, but now we're gonna use a linear transformation. Just transformation. Okay, after we transform this domain into this bottom domain here, this function will become easier. Okay, so what kind of transformation we're gonna do here? So let's consider this transformation here. So consider following transformation. So what's this transformation here? So this transformation is hindered by your function. Okay, inside got x minus y, x plus y. So why not we just introduce new variable that is s minus y and x plus y. Okay, we just introduce this so that my cosine and sine only depend on one variable. Okay, instead of depending on two variables. So I reduce the complexness there. Okay, so when I do this, what happens? What happened to my xy in terms of these two new variables here? So x will become u plus v over 2. Okay, good. V become v minus u over 2. So under this new transformation here, you need to see how your domain changes. Okay. So how to determine this? Well, I mean, we can start with boundary first, right? So let's start with boundary line here. So let's look at boundary line here. Okay, let's look at boundary line here. Well, so what is R1? Can you quickly tell me what is R1 here? How to describe this line? This line is connecting the origin with pi pi. So what line is this? Y equals to x. Okay, but how do you control your x? Your x is going from 0 to pi only. Okay, so in this case, what's the new u and the v? What does it become? What happened to all the points after transformation? For this line, for every point in this line, what is u? U is equals to x minus y. But on this line, this point will satisfy y equals to x. So all these points will correspond to the point where u equals to 0. Okay. How about v? V is x plus y. But on this point, what is y? Y equals to x. So you really get 2x here. Okay, is this useful or not? Okay, what does this tell you? This tells you what? This tells you the range of u equals to 0. Where does the u equals 0 range from? Your x can take what value? 0 to pi. But your v is 2x. So your v range from where to where? To 0 to 2 pi. Good. So your v will range from 0 to 2 pi. Okay, so what's this line? U equals 0 and then cut v at 0 to 2 pi. This is the u axis. Okay, u axis here. So your R1 gets sent to here. Okay, under this map. Okay, u equals to 0 and then v from 这吗？是这个吗？ Let's check. Oh, sorry, 讲错了，应该是这个。U equals to 0 and then v from 0 to 2. Okay. Okay, next. Where's, oh, sorry, this is R1. So this is called R2 and this is called R3. So how about R2? What's this vertical line here? This vertical line here is exactly x equals to pi. Okay, but how do you control y? Y is going from minus pi to pi. Okay. Right, so we want to see where this line get transformed into. In this case here, how do you check? Any idea? U equal pi minus y, and then what else you can do?
You will do the venture.
U range from U range from where to where? From 0 to 2 pi. Okay, sure. And then V, what happened to V? Y plus Y. Then V is going from 0 to 2 pi also. But how do you draw this line or what? How do you draw it? So now you only get the range, right? Okay, but what's that line? What's the new line here? You get a new line here. So you need to have some relation between V and U, right? Can you get any useful relation between V and U? V plus U, V plus U, V plus U equals to 2 pi y. You are using the relation here. Okay. But V plus U equals to 2 pi means what? U equals to minus V plus 2 pi. So this is a linear line in the UV plane. Okay, so what's this linear line here? So U equals to minus V is like this, right? But you're shifting out by 2 pi. So you're intersecting V axis with 2 pi, and then you can check that you also intersect U axis with 2 pi. Okay, so the new R2 is here. Okay, the new R2 is here. Okay, how about last one? Last one should be similar to R1. Okay, so R3 is just y equals to minus x, and then x is bounding from 0 to pi, and then you should check that u equals to 2x, and then u is ranging from 0 to 2 pi, and then v is just 0. Okay, which is this. Okay. Are you worried about something or not? How do you know the inside point gets sent to inside and not outside? You worried? 对啊，有可能啊，可能有可能诶。Sorry. So I mean, why this everything inside this first triangle here gets sent to the new triangle inside me? Can it send outside or not? Can the blue part stay outside? Can no. You know why I'm asking? 懂得为什么吗？有可能吗？不可能，为什么？不太什么？哦，你不懂我讲什么？就是说so first of all, the domain we're looking at is the point inside the triangle, right? Okay, so after transformation, we know where the boundary sends to, but how do we decide where the point inside the triangle gets sent to? Is it outside a new triangle or inside a new triangle? What do you think? You can check any random point inside, but there's infinitely many points inside, right? 你不能 check 了。I mean, one way to do it is you can slice up your spaces using for example, the vertical line here. And then you should see that these vertical line here, right, should send into some slanted line inside here. Yeah, one way to do this. Yeah. Okay. One way to do this. Yeah, there are more way to do this when you do higher level max. You should see that a compact set should send to compact set with a continuous mapping. Yeah. So there's something special about this set here. It's compact. Okay, imagine if you send to something outside it is unbounded. How you send a bounded stuff to unbounded 你可以拿一块布遮完整个宇宙嘛？不能嘛，对不对？ You cannot use a bounded stuff to cover unbounded stuff. And then can you like simply move your point outside or not? Okay, this really depends on what mapping you use here, what transformation you use. But the transformation used here is continuous. Okay, so you cannot have some random point jump outside the original domain. Yeah. Okay. Yeah. So continuous means what actually? Continuous actually means that the nearby points will stay nearby. Okay, after the mapping. Okay, when is it a function continuous? Okay, what does the epsilon delta do to you is before that it is closed, after mapping also closed. Okay, this is continuous, what it means by continuous. Okay, no? Yeah. Okay. Okay, we haven't done actually. This is just transforming the domain only. Let's finish out this computation and then we will break. So we want to use this theorem here. Okay, we need to do this transformation using this to compute. Sorry, to compute the integral. So we have a mapping from uv to xy now. So what do we need to do next? We need to compute the juv. Okay, so what's the juv here? So let's write down. So what's juv here? If you follow the order, is del x, del u, del x, del v, and then del y, del u, del y, del v. Okay, so in this case here, if you quickly compute, it's half, half, minus half, and half. So in this case here, you are just stretched by a constant. Okay, in polar coordinate, you stretch by radius. 合理吗？ Stretch by radius. Stretch by radius means what? When the radius that you consider, the polar rectangle that you consider is further away from the radius, you get stretched more. 合理吗？合理吗？ If you have a polar rectangle at a larger radius, 是不是把你正常的 rectangle 拉得更长一点？你想想看，想想看。Radius 越长，你的 rectangle 被拉得越长。So depend on R. But in this case, it's constant. Okay, in this case, it's constant. Okay. So how do we change this rectangle? How do we change the integral? So let's start with. Let's start with the original integral here. What is our transformation here? So t of uv to xy. So what's this map here? Let's recall. So this map is u plus v over 2, comma v minus u over 2. Okay. Hey, note that we find u and v using xy first, and then only then we find xy in terms of u and v. So it's like invertible. Okay, you can go from the right hand side to the left hand side to the right hand side. Okay, it's invertible around there. Okay, so this is what we did. So we change variable to uv now. What it becomes a new domain. So previously R was like this, and then now X is look like what? look at a right angle triangle now. Okay, and then x minus y become u, x plus y become v. Okay, so you can see that actually we are recording the two set of change of variable, one inside my function, the other one inside the transformation here, multiplied by the Jacobian. Okay, so what's the new integration domain here? Let's say we want to do uv here. Can we do uv? So let's say if we do uv here, meaning we want to fix v first with a constant, and then we want to fix u, depend on v. Okay, so v is going from where to where? 0 to 2 pi. So if we go from 0 to 2 pi, how you control your u? How to control u? So if you fix v, how to control u? What is the lower bound? What is the upper bound? So the lower bound is 0, upper bound is 2 pi minus 2 pi minus v. Okay, so this is the which line? This is the R2 line that we found just now. Okay, R2 line. 2 pi minus v. Okay. Yeah. All right, so if we use this direction, we will get half of 0, 2 pi, 2 pi minus v, then cos u sine v du dv. Okay, so now in this case here, this integral is easier to compute, right? Because if you want to compute a partial integration on u, you just treat sine v as a constant, and then you just simply integrate. But previously, if you want to treat either one of them as a constant, you still have a product to integrate. Okay, but now you just make the other term in the product constant. Okay, after doing this. Okay, Anna? Okay, so if you quickly compute this, let's quickly do it. I think it's not too. Yes. So next step we get this, and if you compute it, you get sine v, sine 2 pi minus v, but this is just a shift of sine, which is, if you shift it by 2 pi, what do you get? Sine. You get a minus sine v. Okay, because this sine v is odd. Yeah, it is odd. And then if you compute the sine square, so you can see sine square keep popping out in the integral, so make sure you know it. By the way, in the final exam, you will receive a definition and theorem sheets, so you don't need to copy, you don't need to bring it. I'll release before final exam, so you can use it to do your revision. Okay, so make sure you are familiar with the definition and theorem sheets provided. So if you integrate this, you get 1/4 of sine 2v over 2 minus v from 0 to 2 pi. So if you compute it, you get minus pi over 2. Okay, so really we want to put a factor on Jacobian. I mean, not put a factor, put an absolute value on Jacobian, because we don't want the sign of Jacobian change our area or volume that we compute. It's just changed by size, not by sign. By size. Okay. Okay, so next term, next week, we will try and do some more exercise on this multiple integral, and then also do some Jacobian on triple integral. Okay, and then after that, we can go to vector function. We'll quickly review vector functions, and then we will go to the end vector calculus on the Green's theorem, Stokes theorem, and divergence theorem. And then we will finish the course. Okay. Yeah. Close to the end. See you next week.